What if the next scientific breakthrough didn't take a lifetime? Right now, AI research is an exclusive club, big tech, elite universities, and massive funding. But the walls are coming down. Meet AI Supervisor, your personal world-class research team active 24/7. It uses the Research World Model, a living, breathing knowledge graph that never forgets. It doesn't just read papers. It probes, tests, and self-corrects across every scientific domain. 80% precision, unmatched alignment, infinite curiosity. The era of exclusive discovery is over. Welcome to the future of science. This is AI Supervisor.
What if you could have your very own personal world-class AI research team? I mean, one that's ready to go, ready to explore any idea you're curious about. Well, today, we're diving into a brand new system that's trying to do exactly that, and it could totally blow the doors off the exclusive world of scientific discovery for everyone. It all really starts with curiosity, right? That's the engine of all discovery. Einstein absolutely nailed it here, that drive to just ask why or what if. That's inside all of us. But here's the thing. Being passionately curious, well, it often isn't enough. You hit a wall built out of institutional red tape, funding problems, and, just needing an expert to guide you. So let's talk about that wall. Let's break it down. Because the problem isn't a lack of ideas. It's the very structure of how AI research is done today. AI research right now, it honestly feels like an exclusive club. The whole thing is largely driven by what a few big corporations and top universities think is important, not by the amazing, diverse curiosity of individuals out there. So if your brilliant idea doesn't happen to line up with a project that's already funded, you're pretty much out of luck. This model just can't keep up with the explosion of interest in AI around the world. So the big idea here isn't just about giving more people access to some new tools. No, it's way bigger. It's about giving every single person their own AI supervisor and their own research team. And this chart really shows you the massive shift we're talking about. Current systems are usually stateless. That means they forget everything from one conversation to the next. AI Supervisor, though, it uses a persistent world model that remembers and learns. We're moving from a rigid, linear process to active, dynamic exploration, from needing a human supervisor to having an automated one. And this is the biggest part. It changes the goal from just spitting out text to actually creating new knowledge. Okay, let's get into the good stuff, because this is where it gets really, really cool. How does this system actually think? What makes it so different from just another souped-up chatbot? So at the very heart of this whole thing is this knowledge graph. You can think of it as a shared brain for all the AI agents. It's not just a straight line from A to B. It starts with the AI agents reading all the literature to build out this initial graph. Then they actively start poking at it, looking for holes and gaps in what we know. But the real magic happens in phase 3, this self-correcting development. See all those loops? The agents are constantly reading from, writing to, and updating the central brain. They test out ideas, figure out why things failed, and feed all that learning right back into the graph. It's a living, breathing system. And in that central brain has a name, the Research World Model, or RWM. Seriously, picture a living map of an entire scientific field. It doesn't just store papers. It actually understands the connections between different methods, the limitations of every approach, and this is key, it keeps track of what's just a claim versus what has actually been proven and verified. And when we zoom in on this RWM, you can see it's not just a simple list of facts. It is a complex, interconnected web. Papers are linked to the methods they use. Methods are tied to performance benchmarks, and crucially, it tracks their limitations. This is how it finds the real gaps in a field, the important stuff. And it's not static. It's always being updated by reading new papers, looking at code, and even getting feedback from the community. Now, let's talk about the next big innovation, this self-correcting loop. This is how the system actually comes up with new ideas. It starts by playing the 5 whys game, really digging down to the root cause of a problem. Then, and this is so smart, instead of just looking for answers in its own backyard, it searches across totally different scientific fields. Like a problem in AI safety might find an answer in economics or biology. Multiple AI agents then test these ideas in parallel, and to move forward, they have to pass this really tough 10-point quality check. And if an idea fails, the system doesn't just try a slightly different solution, it goes all the way back and rethinks the entire problem. So that's the theory. It sounds amazing, right? But does it actually work? You know the saying, extraordinary claims require extraordinary evidence. So let's look at the numbers. All right, this first test was all about how well this system could find meaningful research gaps. And the results are just, wow. AI Supervisor hit a precision of over 80%. But look at that best alignment score, 4.44 out of 5. What that means is the ideas it suggested were incredibly close to real, actual breakthroughs that were later published. It's a huge leap ahead of the other automated methods. And this chart just makes it super clear. That best alignment score for AI Supervisor is just in another league. It's proof that this whole research world model isn't just a gimmick. It gives the system a much deeper understanding of the science, which helps it focus on the problems that actually matter. Okay, but what about coming up with solutions? This table shows the novelty score for the new methods it created. The system's unique approach, combining that deep dive analysis with a cross-domain search, scored a 20.6 out of 25. That is a massive jump over the other approaches. And get this, a naive cross-domain search actually did the worst. That tells you that just grabbing a random idea from another field isn't enough. The real genius is in understanding why it works and how to adapt it properly. So, what does this all add up to? I mean, it's about so much more than just a cool new tool. This is pointing toward a fundamental change in how we think about scientific knowledge itself. Just imagine a future where every single researcher has their own research world model. And these models could connect to each other, sharing verified findings, creating this huge, living, distributed network of knowledge. Your reputation wouldn't just be about the papers you publish, but about the verified contributions you make to this shared resource. This could completely democratize the entire scientific process, from that first spark of an idea all the way to validation. And that brings us to one last really powerful question. If anyone with a spark of curiosity can have access to a world-class research team, what are we going to discover next? What problems that we thought were too small or too hard will we finally be able to solve? The possibilities are, well, they're just staggering to think about.